Welcome to another day on the Journey Shake Chem. Please do the 2 warm-up questions to the best of your ability, and we'll discuss them in a moment. In number 1, we have a problem for the heat of the reaction, or the enthalpy of reaction would be the same type of problem. And you'll notice that you were given a decomposition. So again, we're reviewing our decompositions. And in this case, I have a metallic carbonate. And metallic carbonates always decompose to a base anhydride, and carbon dioxide is the common molecule that we get out of carbonates. Now, the formula that I'm going to follow is that the heat of the reaction, and I use Rxn for reaction, is equal to the sum of the heat of the products minus the sum of the heat of the reactants. This is where I use my mega brackets. I look at my products, and I have 1 mole, 1 is the coefficient for cesium oxide, 1 mole of cesium oxide, and the amount of heat for 1 mole of cesium oxide. And the amount of heat is negative 75.9 kilojoules. Plus, I have 1 mole of carbon dioxide. And each mole of carbon dioxide has minus 393.5 kilojoules, is 1 mole of carbon dioxide. And that would be the products. Minus, I have 1 mole of the cesium carbonate and 1 mole of cesium carbonate has the amount of heat of formation of negative 267.0 kilojoules. Now, it's possible that if you're using a different chart from a different text that you may find slightly different numbers, but they should be very close. Then I just follow through with the math. And I have minus 75.9 minus, because plus a negative gives me a negative, 393.5. And a negative is a positive, 267.0. And therefore, I get negative 202.0 kilojoules. Remember, we're taking the heats of reactions to the tens place. And because the number comes out exactly, I need to add that 0.0. Now, because the sign is negative, that means my reaction is exothermic, which means that heat is released. And that's number 1. In number 2, we are determining the amount of heat. And I'm given 15 liters of water. Now, 15 liters of water does not have a mass of 15 grams. Therefore, I must change my liters to milliliters using a conversion factor. You know how much I love those conversion factors. And then I know the density of water is that 1 gram is equal to 1 milliliter. And therefore, I have 15,000 grams. And the change in temperature is 3 degrees Celsius. And the specific heat capacity for water is 4.18 joules per gram degrees Celsius. And therefore, the grams are going to cancel and the degrees Celsius cancels, leaving me joules as my unit. And when I do the math, I get 188,100, and I look back at my original problem, and the number with the least number of significant digits is how I express my answer. And therefore, my answer is 188,000 joules is my final answer for number 2. And last night you had a worksheet to do, and you need to review that with your facilitator. And this evening you will have the other side to do for tomorrow. So we're going to have plenty of practice for you to do before we have an assessment. And that's always good. Well, that was some fun, and I can't wait to see you tomorrow. Bye.